Welcome to the Connectivity Without Chaos podcast. Today we discuss the unique wireless network challenges in higher learning. And imagine trying to wire a 19th century cathedral for thousands of people screaming 4K video at the exact same time.
Yeah, that is essentially the daily reality for a university IT department, honestly.
Well, right. So our mission for this deep dive today is exploring why keeping a modern campus connected is, well, basically one of the most complex IT nightmares imaginable. We are pulling from a stack of network engineering white papers and university case studies to really understand this collision of ancient architecture and, cutting-edge device density.
It is a totally fascinating collision. I mean, you have these structures built way before electricity, let alone the internet, trying to support massive digital demands.
It's like setting up campus Wi-Fi is essentially like trying to install a modern fiber optic nervous system into a 200-year-old skeleton.
That is a perfect analogy, yeah. Think about those beautiful historic lecture halls, right? They feature incredibly dense building materials, thick stone walls, and solid marble columns that actively absorb and block wireless signals.
Oh, wow. So they just eat the signal completely.
Pretty much, yeah. And if you try to run cables to fix those dead zones, you often hit restricted access areas. Or even worse, you find hazardous materials like asbestos hidden inside those historic walls.
Yikes. So a 200-year-old stone wall acts like a Wi-Fi fortress, but surely the brand new multi-million-dollar STEM buildings are perfectly optimized for this.
Well, you would think so, but modern spaces introduce a totally different kind of headache.
Wait, really? How so?
Take a state-of-the-art robotics or electronics lab. The motors and high-voltage gear in those rooms are essentially pumping out electromagnetic noise.
Oh, I didn't even think of that.
Right, they broadcast this junk radio wave interference that completely drowns out delicate Wi-Fi signals. Plus, you have these dynamic mixed-use spaces, like a gymnasium, just a big open room most days, but...
But overnight, it transforms into a high-density exam hall.
Exactly, with hundreds of students suddenly needing simultaneous, flawless connections.
So you somehow engineer a network that survives stone walls, asbestos, and noisy robotics labs. But a network is only as stable as the people using it, right? Which brings us to the human element.
Absolutely. I mean, in a standard corporate office, IT controls the laptops and standardizes the hardware. But on a campus, you face the bring-your-own-device explosion.
The BYOD chaos.
Yeah, a single student might walk into a lecture hall connected to 4 devices simultaneously.
It's true. I don't think I've seen a college student with fewer than 3 screens glowing in front of them at any given time.
Right.
A laptop, a smartphone, a tablet, maybe a gaming console back in the dorm. But the part of these case studies that really blew my mind is the rogue AP problem.
Oh man, this is an absolute nightmare for network administrators.
Tell us about it.
Well, when hundreds of students plug in their own personal routers or set up mobile hotspots, they create massive co-channel interference.
Because they're basically shouting over the university's official network on the exact same radio frequencies, right?
Precisely. And not to mention, those unsecured personal hotspots create major security vulnerabilities, just opening the door for spoofing or hacking.
So if you are listening to this deep dive in your dorm room on a personal mobile hotspot right now, you are actively creating the interference that is slowing down your entire floor.
You absolutely are.
But let me push back here for a second. When people complain about slow Wi-Fi, why can't the university just install more access points? Just put a router in every single room.
It is a super logical assumption, but blindly adding hardware actually makes performance much worse.
Really?
Yeah, it's like trying to solve the problem of a noisy room by adding more people shouting with megaphones.
Okay, so by adding more routers, you aren't actually adding capacity.
No, you're just raising the noise floor so nobody can hear the actual data. You have to strategically design the capacity, not just blast more signal.
That makes a lot of sense. And, students don't just stay inside either. They expect flawless connectivity on the campus lawns and walking paths.
Which pushes the network right out into the elements.
Right, which has to be a whole other set of physical hurdles you don't face indoors.
Oh, definitely. Outside, you lack obvious mounting spots or power sources.
Yeah.
IT teams have to get incredibly creative.
Like what, hiding them in trees?
Almost. They are weatherproofing equipment and hiding access points inside light poles just to maintain the campus aesthetic while surviving rain and snow.
That is wild. And just when they finish, they basically have to do it all over again. The engineering papers highlight an amazing stat, which is that 80% of network design projects are actually redesigns.
Yeah, that is the reality of rapid tech shifts.
Right.
We constantly see jumps in standards, moving from Wi-Fi 6 to Wi-Fi 7, for example.
So it never really ends.
Never. Because of these bandwidth-heavy demands and constant wear and tear, a campus network really only has a lifespan of about 5 to 7 years.
Wow, it really is a constantly moving target, which leaves you, the listener, with a pretty provocative thought to mull over.
Yeah, where does it end?
Right. As universities increasingly adopt bandwidth-heavy, augmented, and virtual reality for immersive learning, will the physical campus network eventually have to expand into a decentralized, citywide mesh just to keep up with the students?
It is a really fascinating question. I mean, the campus of the future might not have digital borders at all.
Thank you for listening to the Connectivity Without Chaos podcast. If you enjoyed this podcast, please like and subscribe. For more insights, see our Substack blogs under Connectivity Without Chaos.